So as I have written up here for you, a relation is a set of ordered pairs. That's one way people define it. Another way you can define it is anything that can be graphed is also going to be a relation. So if you can write it as a set of numbers, ordered pairs, or you can graph it, it's going to be a relation. So our example we gave to you here are the points -2, 1, 3, 0, 4, 3. That would be a relation because it's a collection of some points. Let's see here. So as another example, as I said, anything that you can graph. So if I have a graph here, I could just have a series of points like that. That's a relation because I can graph those points. Anything we've graphed so far, like for example, a line would be a relation because you could graph it. You could also write it as some points. Our parabolas that we've graphed so far, those would be relations because you could graph them and you can write them as a set of points. I could draw a nice little spiral on here. That would also be a relation. I could graph it and I could also write a whole bunch of points for that. So all those different things are relations. So basically everything we're dealing with is a relation. So a more specific one is a function. A function is a set of ordered pairs in which the domain, which we also refer to as your input values, has only one range to go with it. So the way we usually kind of shorten that definition down is we say that the x's do not repeat. If your x values repeat, that means there's more than one y value that goes with it. So you can't have that. Your x's cannot repeat. And then that right there, that's our function notation. We read that as f of x. So that just means it's a function. So if we take a look at our example up above, this one right here, our domain is the set of all your input values, also known as all your x values. So if they asked us to identify what the domain is, we would simply write 2, 3, and 4, because those are all of the x values from those 3 points up above. Now I put those little squiggly braces around it because they gave us the points up here with the squiggly braces. We refer to that as set notation. So I have to give the domain in the same way. You've always got to keep your notations the same. So then our range would be your y values, your output values. Who could tell me what would be my output values up here? Perfect. 1, 0, and 3, my y values. Now you've got to make sure you write them in order, though, from least to greatest. So I would write it actually as 0, 1, and 3. Always least to greatest in those. So that's one way to identify our domain and range. We're going to be doing a lot more with that throughout the unit. Our vertical line test, that allows us to check to see if a relation is a function. So you would do a vertical line on the graph. If it passes through more than one point, then it is not a function. And we'll go through that down below. And then this is just saying relations and functions can be represented by tables, set of points, or graphs. We just have lots of different ways we can represent them. So let's take a look at our examples down here. They want us to first determine if this is a function or not. So since for these first two I have pictures of graphs, I'm going to use my vertical line test. And with the vertical line test, you have to be able to draw the vertical line anywhere on the graph. And how many times does this hit? 2. It would hit 2 here, it would hit 2 here. So this is not a function. Oops, I spelled that wrong. Function. So because my vertical line hit it twice, at any point in the graph, it doesn't matter where you draw it, if it hits it twice, it's not a function. So over in my second picture over there, though, if I draw my vertical line somewhere, how many times does it hit my graph? Once. And then I always test another place, still only hits it once. Test over there, it still only hits it once. So this one is a function. Again, what that vertical line is testing is how many x values do you have at that point in time. So you only want one x value at a time. So now when you're given points or tables of values, you want to look at your x values to determine if it's a function or not. So if I look at number 3, do any of those x values repeat? Yeah, the 1 is repeated, so this one is not a function. So what I want to just practice for a second is finding our domain and range of these. I didn't do it of the graphs because we're going to get into that in a couple of days. That's something different. But for your points, those ones are easier. We have a 1, a 3, a 1, a 8, and a 1. Whenever you have values that repeat like our 1 does, you don't write it that many times. You still only write the number once. So our domain would be 1, 3, and 8. So then our range for this one, look at our y values. I got a 2, a 4, a 5, a 7, and a 9. None of those are repeated, so I'm just going to write those in order from least to greatest. I do this because you may be asked to find your domain and range on your homework later. So let's take a look at number 4. So again, we got to first determine if it's a function. So I go through and I look at my x values. I got a 5, an 8, a 9, and a 10. Would that be a function? Yes, because none of our x values are repeated. So again, I just want you to practice writing what is your domain, what is your range. Can anybody tell me what our domain would be for number 4? Our domain would be 5, 8, 9, and 10. Our range is what? 2, 3, and 4. Because remember, the 4 is there twice, but we only write it once. So our range would be 2, 3, 4. So now with your tables in 5 and 6, I always like the tables because they just line up your x's. I think it makes it a little easier to see. So if we look at our x values, do any of those repeat? No, so this would be a function. None of our x values repeated. So how about for number 6? Not a function. Which one repeated? The number 1. The number 1 got repeated, so that makes it not a function. Questions on that so far? Okay, so if we take a look at the back, we're still dealing with our domain and range. It's just these are different ways that they would ask you about your domain and range. So number 7 tells us to evaluate a function for a given value. We got to replace the x. So right here we're given this function, f of x equals 2x plus 5. They told us to find f of 3. So what you have to keep in mind is what letter do we normally have in the parentheses here? X. So this is telling us we're looking for when x equals a 3. So we're plugging that 3 in for the letter x. So going back to my function then, what I'm going to do is everywhere I see an x, I'm going to plug a 3 in instead. So it becomes f of 3 equals 2 times 3 plus 5. So let's figure this out. So what do we get when we do 2 times 3? 6. And then 6 plus 5? 11. So f of 3 equals 11. So again, whatever number's in the parentheses, you plug that in for your x. Now 8's another way of asking it. They're just giving it to you in a table of values form, but it's the same thing. They're telling you to take the 1, the 2, and the 3, plug it in for n, and then let's see what we get. So instead of 3n minus 1, we would do 3 times 1 minus 1. Which, what would this give us? 3 times 1 minus 1? 2. And then we got to do 3 times 2 minus 1 would give us 5, yeah. And then 3 times 3 minus 1 gives us 8. Bless you. So again, number 9, asking us to do the same thing. They give us a function, g of x equals x plus 4. They gave you your domain. These are our domain values, -1, 4, and 7. So what they're asking us to do is they're asking us to go and plug in -1 for your x. So what do we get? -1 plus 4? 3. So then after you've done that, they're then asking you to plug in a 4 for your x. So instead of x plus 4, we now have 4 plus 4. Which 4 plus 4 gives us? Come on, 4 plus 4? 8. And then what are we going to plug in for the last one? 7. So now we're going to plug in a 7. G of 7 equals 7 plus 4. What's up, Johnny?
Do you have to do it that way, or can you make the table?
If you have to show work, you have to show it this way. Okay. Unless you did the table like I did up here, where you're still showing that you're plugging everything in. You still have to show us how you get the answer. But yes, you could do it that way. Somebody was trying to do a little table earlier, and you got to show us work still. So G of 7 would equal what? 11. Now, since they gave you the domain like this, you have to give the range the same way. So we would write our range as 3, 8, 11. You got to remember to answer it the same way that they gave it to you. Questions on those ones so far? Alright, so now this middle part gets a little bit different, and some people struggle with it a little bit because it is different than what we've done before. So this is telling us to find the value of f of -1. So what they did this time is they gave us a table of values as opposed to an equation. So again, we have to remember what letter is normally in those parentheses. An x. So this means we're looking for when x is -1. So if we go over to our table to where x is -1, what's our answer? 4. So you don't have to calculate anything. They've done all the calculations for you. You're just looking for the correct answer. So for number 11, it says find the value of 3 times f of 2. So I got to do 3 times whatever f of 2 equals. So again, that 2 is in the x spot. So we got to go to where x equals 2. X equals 2 gives us a what? -5. So that means it's 3 times -5. Which, what do we get when we do 3 times -5? -15. So then 12, first one, we got to go to where x is 5. So if we go to where x is 5, our answer is a what? So f of 5 gets replaced with a negative 14. Then it's minus 2 times f of 0. So we got to go to where x is 0. Yep, if we look over, we get a 1. So 2 times 1 just gives us a what? 2. So we have negative 14 minus 2, which gives us a final answer of negative 16. And then these last 3 are kind of like the middle 3. This time they gave us a graph as opposed to a table, so we've got to use the graph to get our answers for this. Let's go to 14 and 15 first, and then we'll come back to 13 in a second. So for 14, we need to find g of 3 first. So again, we're looking at when x equals 3. So on my graph, I'm going to go to where x is 3. If I look down to where it actually is on the graph, what's the y value for that? X is 3. My graph is actually down here. If we look over, it's a negative 1. Yeah, they all go by 1s. So g of 3 is negative 1. Subtract a 1, what do we get? Negative 2. Alright, so let's try 15. It says negative 2 times g of negative 2. So I got my negative 2 there, my parentheses. We have to figure out what is g of negative 2. So we go to where x is negative 2. Look down. I'm going to line this up right. Looks like it hits it down here, right? I'm not very good with straight lines. So what is that value there? Bless you.
6.
Negative 6. So then negative 2 times negative 6 would give us a 12. So those are like the other ones we were doing in the middle. 13 is different because it told us to find the value of x. So we don't know x yet. That's the whole point of the answer, is to find the value of x. So I know my answer needs to be an x equals something. They want for when the function equals a 3. So that means I got to go up to 3. Where does my graph hit that line? When x equals 1. So as I said, I know those ones are a little trickier. That's only going to come with practice.